Hello, everyone, and welcome back. We're going to be talking about the assessment preparation 1C today for Math 154. Just going to start right away here with question 1. Let me get back to where you can see all of my screen and what I'm writing on my whiteboard. All right, so all horses are animals. Is that a categorical proposition in standard form? Yes, it is, where the subject is horses and the predicate is things that are animals. So 2, some flight attendants are men. Yes, it is. Subject is flight attendants. Predicate is men. No positive numbers are negative numbers. Is that a categorical proposition? Yes, it is. Subject is positive numbers. Predicate is negative numbers. Some singers are not children. Yes, it is. Subject is singers. Predicate is, you could say children or not children. I think, check here. Yes, predicate set as children. So you can go ahead, you can draw Venn diagrams for these with those two sets, and you can put an X in there for where the thing is that you're talking about. Okay, beggars can't be choosers. That's not in standard form, but the subject is beggars. The predicate is choosers, and you could rewrite that as no beggars are choosers, something like that. Movies are entertaining. That's not in your standard form. So you need to have like an all or a some or an every or something like that for it to be in standard form. So all movies are entertaining. That's standard form. Some dogs are adorable. That is in standard form. Let me go back to movies and entertaining. Subject is movies. Predicate is things that are entertaining. Subject here are dogs. Predicate is things that are adorable, right? Okay, so not even gonna write all that out there for you. Following Venn diagram describes the desserts people ordered at a party. Use it to determine how many people ordered cake. So there are 7 people that ordered only cake. There's 21 people that ordered cake and ice cream. Altogether, there's 28 people that ordered cake. Determine how many people ordered ice cream but not cake. 15. How many Fords are on the lot? 20 plus 3 is going to be 23, because there's 3 red Fords and there's 20 Fords that are not red. Determine how many cars that are on the lot that are not red. 20 plus 35 is 55. Right? Not red is going to be everything outside the red circle. 20 plus 35 is going to be 55. How many customers ordered call waiting? 36 plus 40 is 76. How many customers did not order caller ID? That's going to be 40 plus 27 is going to be 67. How many chocolate chip cookies do not also have walnuts? So that's going to be 15. 15 chocolate chip cookies without walnuts. How many chocolate chip cookies? How many are neither chocolate chip nor have walnuts? That's 7, right? That's what's on the outside here. In a complex of 60 apartments, 40 have cable television, 25 have a dishwasher, and 13 apartments have both cable TV and a dishwasher. So make your Venn diagram here: cable, TV, dishwasher, there's going to be things out here that have neither. It says that there's 13 apartments that have both. 25 have a dishwasher total, so there's another 12 over here. 40 total have cable TV, so that's 27. There were right there is 40, 52. There were 60 apartments total. So there's 8 that have neither, right? So draw your Venn diagram. It looks like that. Okay, this is number 17. Let's look at number 18 in a survey of 80 pet owners, also, and is equal to 60 up here. Should have 60 things total. 40, 52, 60. All right. It says n equals 80 for this one. 50 had a dog, 33 had a cat, dog, cat. There are a few who have both, right? So 12 had both. 33 had a cat. So 33 minus 12 is 21. And 50 minus 12 is 38. And this is 50, 71. So there's 9 people that had neither. In a freshman class of 50 students, 30 students were taking math, 24 students taking history, 15 students in both math and history. So math, history. You have to leave some space here for people taking neither. N is equal to 50. And it says 15 students were taking both. Then it says that there were 30 taking math, so there's another 15 here. 24 taking history, another 9 students here. 39 of the 50, so there's 11 out here taking neither. So very helpful when we're figuring out things with logic and sets and subsets and things like that. We'll get there actually in the next assessment. We'll do more with, instead of just overlapping sets here, with circles inside of circles. Patients in a hypothetical hospital on a single day were taking antibiotics, blood pressure medicine, and pain medicine here. So we've got 3 different circles that overlap. And they want to call this set A, want to call this set BP. They want to call this set down here just P for pain. All right, so let's start with the easy ones. Patients that were taking none of them. Out here is 5, all of them. Here is 21. Now from this 21, let's look for people that were taking A and BP. Let's see. A and BP only is 15. Right? So A and BP only, 15. And then A and P only is 25. That goes in there. And then BP and P only is 18. So they did give us all the little wedges here. A only is 13. P only is 23. BP only is 7. That should fill everything up, and it wants to know. Okay, there it is. So there's your 3-circle Venn diagram that summarizes the results. That's number 20. Every little circle there has a number filled in with it. And there's a number on the outside representing everyone. And if I wanted to add this up, N is going to have to be, let's see, this is 28, 35, 60, 81, 99, 122, 127. I think if I counted that right, N equals 127. Just check that with my calculator. 13 plus 15 plus 7 plus 25 plus 21 plus 18 plus 23 plus 5. Yep, 127 is my total number of people that were in that hypothetical hospital that day. All right, clear all that. Draw a Venn diagram to represent the information, use it. And no other assumptions to answer the question. All right, all cars have wheels. So here are things with wheels. Here are cars. This is what I was talking about with subsets just a second ago. All trucks have wheels. So I don't know. I don't, you know, nothing about the problem tells me whether there's something that could be both a car and a truck, right? I just know that they both have wheels. So I'm going to assume that there's an overlap there. Some toys have wheels. Okay. Maybe there are toys that are cars. Maybe there are toys that are trucks. I don't know. So I'm going to draw overlaps for those too. There's toys. And it says some of them, not all of them, some of them. So toys. It says only some of them have wheels. So there's part of it that's outside. No grandmothers have wheels. So grandmothers are out here. All right. Could a car be both a truck and a toy? Sure. By the Venn diagram here, I could have, change my color here. I could have right here a car that is a truck and a toy. Absolutely. So yes, that could happen. It's hard to forget everything else that you think that you know. And grandmothers didn't have anything to do with the problem, right? Because it's not in the question. No dogs are cats. So dogs and cats are disjoint. Okay. No gerbils are cats. Well, it doesn't say that gerbils aren't dogs, though. So gerbils could be over here and could overlap with dogs, just that they're not cats. All dogs have fleas. So I don't know. Could gerbils have fleas? Maybe. Could cats have fleas? Maybe. So things with fleas could be this big, maybe. Things with fleas. Okay. Some cats are thirsty. So there's another, circle here that maybe not everything that's thirsty has fleas, but it could encircle some or all of these things. We don't know if all dogs are thirsty. So this is a really hard one to draw, right? Let's just look at the particular question that's asked here. Could a gerbil be a dog? So, could a gerbil be a dog? Yes. According to what I already showed you there, the things with fleas and thirsty and all that extra information that I really didn't need. All right, let's show you that one, 22, just so you see how she drew it here in the answer key. Looks really crazy, right? So here's creatures with fleas. Here's all dogs are in here. Cats are separate from dogs, but maybe cats have fleas. Things that are thirsty. There are some cats, maybe some dogs. I'm not saying, let me see if it says no dogs are thirsty. Make absolutely sure about that. No thirsty creatures have fleas. Okay, so thirsty creatures, some of which are cats, but none of them have fleas. And then there are gerbils, right? No gerbils or cats, but I could have, theoretically, I could have a group that looks like this that is gerbils. Or some of them could be dogs. Some of them could be thirsty, but not cats. Did I miss it? Could some of them be cats? Let me look and see. It's a hard one, right? Yeah, gerbils are here. So they could be thirsty. They could dogs. They could have fleas. They can't be cats. No gerbils or cats. So then the question was, could a gerbil be a dog? Sure, right there, right? That exists, so it's a possibility. All right. So a little crazy, isn't it? But that's a good setup for how we're going to deal with some logic stuff in the next section, where we're going to use Euler diagrams. We're going to put these X's on everything to determine if an argument is valid or invalid. So I'll record that video here in just a second. And let me or your teacher know if you have any questions, or you can come and ask any of the Math Central tutors if you do. See information on how to set up an appointment with a Math Central tutor. Make sure to go to www.reynolds.edu/mathcentral. Have a good day.